For this module, there are two assignments. The first one involves modifying the TV adjust inspect model that we did in video 1. And what I want you to do is add the logic so that 5% of the TVs that fail inspection are immediately rejected. So the model that we did initially, TV had to be adjusted more than 3 times in order to be rejected. This time we want to model the situation where some proportion, 5% in this case, have a serious defect and can't be adjusted, so we want the immediate rejection. Secondly, when a TV is rejected, I want to record a tally so we can count the number of rejections and destroy the entity from within the add-on process where you're making the actual decision. So in the model that we did in video 1, what we did was we transferred the rejected TVs to a sink that we named bad. This time we don't need that sink. What I want you to do is just do the statistical cleanup and then destroy the entity from within the add-on process. And finally, I want you to animate the model to make it look like a TV adjust inspect operation. So for this one, you'll have to use your imagination to just basically make it look good. The second assignment builds on the station logic that we did in video 2, and what we're modeling is an amusement park ride. And so in this ride, passengers arrive at the rate of 9.6 per minute, randomly of course, and they wait in line. About every 10 minutes, exactly 10 minutes, up to 100 passengers move from the line to a room to watch a 7-minute video, so kind of like a holding area. The actual time of the video, or the actual time of the video process, is between 6 and 8 minutes because there's a startup and shutdown associated with the video. After the movie, passengers line up again and are loaded into the ride. The loading process, 2 passengers can be loaded at the same time, and loading takes between 8 and 10 seconds per passenger. After loading, the passengers actually start the ride, so the ride's an individual ride, but has a capacity of 50 passengers, and the ride takes 5 minutes. So the first video should start 15 minutes after the park opens. So you're going to have customer or passenger arrivals starting at time 0 of the simulation, and then the first video should start 15 minutes thereafter to allow a queue to build up. We're interested in a couple of performance metrics. The average group size for the video, so it's up to 100, but if there aren't 100 people in line, then they'll start the video on schedule or every 10 minutes, regardless of how many people are actually there, and you'd like to know what that group size is. The load process utilization, ride process utilization are both of interest. And finally, the waiting time from when a passenger arrives at the line until he or she starts the load process. So once they start getting in the ride, they're satisfied, but the whole time between that they wait in line and that they watch the video, they're unhappy. So you'd like to be able to track that time so that you could potentially make some operational modifications to minimize that. In terms of running your model, you should run for 10 replications of length 160 hours each. Note that to build this model, there are several different ways you could do this, and there are several different Simio methodologies that you could handle this batching and grouping and simultaneous loading and so on. So my strong recommendation is that you spend a little while doing some planning before you actually start jumping in and trying to build the model. And you'll find that this is generally true of most model building exercises as they get more and more, as the models themselves become more and more complex and larger.